Hello student, good morning. I am Dr.A.K. Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have started preparation of alcohol. In that I have discussed preparation of alcohol from alkene. In that we have discussed by two methods, by acid catalyzed hydration and second by hydroboration oxidation. Now I am going to continue. I will discuss now preparation from carbonyl compounds. Preparation of alcohol from carbonyl compounds. First, by reduction of aldehyde and ketone. You know that aldehyde is CHO group and ketone is CO group. Then this CO group is called carbonyl group. CHO, then C double bond O, and then H is there. Then this C double bond O, that is called carbonyl group. Okay, carbon has 4 valency, then C double bond O, one is just left for the alkyl group and other is H. Then C double O group is called carbonyl. Then in ketone also C double O group is there and 2 valencies now remaining, that is for alkyl or aryl group. Then now preparation of alcohol can be done from carbonyl compounds. Then in that first I will discuss by reduction of aldehyde and ketone. Because here C double O group is there, then now this C double O, then here if H is introduced in CO group, then that will become OH. If H is attached to O, then what will happen? Double bond will break, then carbon will have positive charge and oxygen will have negative charge. And when hydrogen comes, then it can make bond with O. And now this C double O group now became OH group, CO and O will attach with H. Then this is actually I told you, just summary in brief what will happen. And now I am telling you in details. Aldehyde and ketones are reduced to the corresponding alcohols by addition of hydrogen in the presence of catalyst. This is also called catalytic hydrogenation. The usual catalyst is a finely divided metal such as platinum, palladium or nickel. It is also prepared by treating aldehydes and ketone with sodium borohydrate in presence of sodium borohydrate NaBH4 or lithium aluminum hydride, means LiAlH4, because these two are reducing agent. Sodium borohydrate and lithium aluminum hydride both are reducing agent. It can supply hydrogen. Aldehyde yield primary alcohols, whereas ketones give secondary alcohols. Then reaction is very simple. RCHO, R is alkyl group, RCHO plus H2 in presence of palladium, it will form RCH2OH. CH2OH means now plus H2 was there, RCHO plus H2, 2 hydrogen is there. Then now these 2 hydrogen now just made bond with carbon and oxygen respectively. Because double bond will break, CO bond will break, then oxygen is electronegative, hence O will have negative charge, carbon will have positive charge, and H2 when it will break, then it will form H plus and H minus, then it will go to the opposite charge, means H plus will go to oxygen and H minus will go to carbon. Then already with carbon one hydrogen was there, RCHO, then now that will become RCH2 and O will become OH. This reaction will take place in the presence of palladium. Now another reaction I am telling you from ketone, RCOR dash. Now COO group is there, then 2 valence is there, then one is attached with R and other is attached with R dash. R may be ethyl, R dash may be ethyl. Okay, both groups are not the same. Then now here again what will happen? Same thing will happen. Okay, RCOO is there, RCOO, double bond O and R dash. Then again this double bond will convert into single bond. Carbon will have positive and oxygen will have negative. Now sodium borohydride will supply hydrogen, 2 hydrogen, then 1 hydrogen will go to carbon and other hydrogen will go to oxygen, means OH is formed. Now it became RCHR dash OH. Now O converted into OH. And one more simple mechanism you can understand, this radical wise also. But radical wise reaction takes place in the presence of UV light. But for understanding purpose, that if you can understand that if double bond is there, then if bond breaks, then one electron will be shared by 2 atoms, means carbon and oxygen. Hydrogen when it breaks, then again you can understand that one electron will be shared by each hydrogen. Then both will go to the, you can say, carbon and oxygen and will make the bond. But here it will, just for understanding purpose you can understand, but this radical formation takes place in presence of UV light. Only for understanding purpose here you can understand this radical wise also, but here generally charge is developed. Electronegative element will become negative charge, because it is electronegative, it will take the electron. Both electron of the bond will be taken by electronegative. Then carbon will have positive charge, it is lacking 2 electron. Then now when hydrogen bond will break, then both electron, total electron is 2, then both electron will be taken by 1 hydrogen. Correct? One electron already hydrogen was having, 1 more taken, then that become H minus, hydride ion, and other hydrogen become H plus. Then it will go to the opposite charge. Okay, means H plus will go to the O minus and H minus will go to the C plus and bond will be formed. Then here RCOO dash in presence of sodium borohydride, it will form RCHR dash and OH. Central carbon, from the central carbon 2 hydrogen attached, one with carbon, other with O. Now second I am telling you by reduction of carboxylic acids. This is also reduction, but carboxylic acid. Alcohol can be prepared by reduction of carboxylic acids and esters. Here you know carboxylic acid RCOOH group is there, and ester RCOOR. In the place of H, R will come. This is the difference between acid and ester. RCOOH. COOH, that is the carboxylic acid group, COOH. But if H will go and R will come, R or R dash, maybe alkyl group same or different, then it will form RCOOR. RCOOH is acid, but RCOOR, R may be same or different, then that will come ester. Okay, hence by reduction of carboxylic acid and ester, alcohol can be formed. Carboxylic acids are reduced to primary alcohol in excellent yields by lithium aluminum hydride. This is a strong reducing agent, means RCOOH in presence of lithium aluminum hydride and H2O, both are required. Okay, lithium aluminum hydride and H2O both are required, then it will form RCH2OH. See, already RCOOH, 2 oxygen was there, then 2 oxygen means what? Here COO. How COOH is there? Then 1 oxygen have double bond, COO, and other valence is with R. 3 is over, and 4th one is attached with O and H, and O is attached with H. Means OH is attached with the carbon. Then total 4 valence is over. 2 with oxygen, 1 with alkyl, 1 with OH. This is the RCOOH. Always you remember this structure. Then now here, because reduction is going on, it means hydrogen will introduce. Then again, same thing will happen. That hydrogen, where will it go? Then now same way double bond will break. Then single bond, it will convert to single bond. Oxygen will have negative charge and carbon will have positive charge. Then these two hydrogen, H2, or you can understand like that, better you understand this only, reduction, that H plus and H minus. H2 will break into H plus and H minus. Then it will go, one H will go to the oxygen and other H will go to the carbon. Correct? Then now 2H2 introduced. Okay. Then here I told you, or you can understand this also, that one RCOOH is there, then one oxygen can be removed. One oxygen can be removed. You can understand in this way also, that 2 hydrogen is there, H2, then H2 and 1 oxygen, CO. Any one oxygen will be removed, because H2 plus O, it will form H2O. It will go. Correct? Then only one OH will remember. Only one OH will remain there. Only one OH will remain, and because 2 oxygen gone, one oxygen gone with 2 hydrogen. Then 1 oxygen gone means now carbon will have, because it went with these things. Oxygen is electronegative. H will come as H plus H plus. Then now this will form water, 2H plus 1O. Then now carbon will have 2 positive. Then now hydrogen, because H plus came, then H minus is remaining. Then that 2 hydrogen ion will come and it is attached with carbon. Then it will form CH2. OH was already, only oxygen is removed. One oxygen is removed and in its place 2 hydrogen joined. One oxygen gone means carbon will come 2 positive. Then 2 negative means 2 H minus means hydrogen ion. That will attach to the carbon. Then now it will form RCH2OH. However, lithium aluminum hydride is an expensive reagent and therefore used for preparing a special chemical only. Commercially, acids are reduced to alcohols by converting them to the ester. It is actually you can make directly alcohol also from the acid, but lithium aluminum hydride is expensive reagent and therefore used for preparing special chemicals only. Commercially, acids are reduced to alcohol by converting them to ester, followed by their reduction using hydrogen in the presence of catalyst. Then this is called catalytic hydrogenation. Means generally it is prepared by acid is converted into ester, and ester when it is reduced in means hydrogenation is done, then it is converted to alcohol. Then first RCOOH is converted into ester. Okay, but here you require to make alcohol. Alcohol is required here, but it is required only in the first step. That time acid is there, RCOOH plus OH in presence of acid. In presence of acid, this reaction takes place and this acid will convert to ester. To convert acid into ester, OH is required, means alcohol is required, ROH. Then you know that acid plus alcohol, it forms ester. How you can understand? You can understand very easily. RCOOH is there. Then when bond will break, OH bond, then H will have H plus, and oxygen will have O negative. O will have negative charge, H will have positive charge. Then this positive charge will go to alcohol, R-OH. That R and OH bond will break. Then R will have positive charge and OH will have negative. Always you remember, OH will be negative charge. Then R will be positive charge. R OH was there. Now it will become R positive, OH negative. Then this R positive will go to the negative charge. Means O was having one negative, R will join there. Then now it became RCOO R. R may be same or different. RCOO R dash you can tell. Both sometimes may be same, maybe sometimes different. Means one time maybe one R may be methyl, other may be alkyl. Okay. Then now see this R from ROH, alcohol joined, and RCOOH now it became RCOO R or RCOO R dash you can tell. And H plus and OH minus, it joined and formed water. Then this reaction takes place in acid medium. This is the first step. And now you got the ester. Then now from the ester you can make the alcohol. How? I have already discussed that now hydrogen will be there. Then now actually this RCOO ester is there. Then RC double bond O. Two oxygens are there. One oxygen has double bond with carbon, and other oxygen is joined by single bond OR, COR. Then C and OR has single bond, but C and oxygen has, first oxygen has double bond, and second oxygen is joined with, one oxygen is joined with double bond, and other oxygen joined by single bond, means OR. That O is joined with carbon with single bond. Then now in the reaction, what will happen, that OR bond actually it will, what will happen, this bond will actually break. This bond will break because this is called actually hydrogenation. Hydrogen you are adding. Then simple way also you can understand that now what will happen, that one oxygen will be removed. Because sufficient hydrogen is there. Then H2 plus O, H2O. It can form H2O. Correct? And now hydrogen is there that can join. Then it will form ROH, because bond I told you it will break. RCOO double bond is there. Then that bond actually will be, that bond will actually both bond will break. Double bond C, double bond oxygen, that bond will also break, and second bond oxygen and carbon, that will also break. Then you understand one by one. Now suppose a double bond, oxygen double bond, that breaks. Then what will happen? One oxygen will have negative charge, carbon will have positive charge. Then two hydrogen will come, and then one hydrogen will go to the negative oxygen, and other hydrogen will go to the positive carbon. Correct? Then now OH group is introduced. One OH is formed. Correct? And now this bond, one more bond will break. I told you that is a carbon and oxygen bond. Single bond what was, that bond will break. Then here again that oxygen will take negative, will get negative charge, and carbon will get positive charge. Correct? When single bond will break, carbon and oxygen, COR is attached, I am talking about that. Then that C and O bond will break. Then that OR will be separate. O will have negative and carbon will have positive. Then again another H2 will come, H plus and H minus. Then same way that H plus will go with OR negative, O negative, OR is there, O is negative. Then H plus will go with that. Okay, H plus will go to the O negative and it will form ROH. And another H minus will come to carbon. Then now carbon will have CH2. Now it became CH2. Correct? Then now it became RCH2OH. RCH2OH. Correct? Means total 4 hydrogen joined, used up. First that is two hydrogen came with two hydrogen joined the carbon, positively charged carbon. And how did they get two positive? I told you. One positive it got when double bond broken that time. And that time two hydrogen used up. And when second bond, single bond carbon oxygen broken, that time again carbon got one positive. And OR got negative, O got negative. Then again two hydrogen used up. One positive went to the negative, and negative hydrogen came to the positive carbon. Hence, two alcohol you got RCH2OH, another is you can say R-OH, correct? Then this I told you how it is alcohol is prepared by reduction of carboxylic acid and ester. Now another method of preparation of alcohol I am telling you, that is from Grignard reagent. Okay, Grignard reagent, always you remember RMGX. Always remember RMGX represent Grignard reagent. Okay, don't forget, always you remember RMGX. And how RMGX is forming, very easily you can understand. Mg is a dipositive, divalent, Mg2 plus. Then R minus can join. Two valence is there. Then one valence will join with one negative, means alkyl. Alkyl is here negatively charged. Okay, and another positive charge will be neutralized by X. X is halide, maybe chloride, bromide, iodide, fluoride, etc. Then two negative, one alkyl group and other halide group joined with Mg2 plus. Mg was having 2 plus, now it is neutralized by 2 negative. One alkyl through alkyl group and other through halide group. Both are negative. That's why it is formed RMGX. 2 positive is neutralized by 2 negative. That is the R and X. You remember, that's why when this bond will break, suppose RMG bond will break, then R will have negative charge and Mg will have one positive. And if you can say this bond breaks Mg and Cl bond, then same way Cl will get negative, Mg will have one positive. This you remember. It will help you in understanding the mechanism of the reaction. Okay, then you can, now I am telling preparation of alcohol from Grignard reagent. Alcohols are produced by the reaction of Grignard reagents with aldehyde and ketones. Now I am telling you, the first step of the reaction is the nucleophilic addition of Grignard reagent to the carbonyl group to form adduct. ADDUCT, adduct means just like addition, just it will join, it will add, that is called adduct. What you will get, that is adduct product. And after that, hydrolysis of the adduct yields an alcohol. The product, what you will get, adduct product, on hydrolysis it will give alcohol. Then here again carbonyl you are using, aldehyde or ketone. Now suppose carbonyl, actually carbonyl group is present in both, in aldehyde also in aldehyde also, in ketone also. Okay. Then now consider carbonyl group, carbonyl, COO group. Then now COO group plus RMGX, Grignard reagent. Then now what will happen? You can understand. CO double bond is there. Then again this double bond will break, and when double bond will break, same situation will happen what I have discussed. Same way oxygen will get one negative, carbon will get one positive. Correct? Means carbocation will be created. It will create carbocation. Okay. Carbon having positive charge is called carbocation. Carbon having negative charge is called carbanion. Okay. Then here double bond will, oxygen double bond, one bond will break. Okay. That is this out of two bond, one bond is what? One bond is sigma bond. That will be a strong bond, it will not break. Then what is another bond? Pi bond. That will break. Okay. Then oxygen electron, both electron will be taken by oxygen, means in pi bond sharing of electron will be there. Then oxygen has shared one electron, carbon has shared one electron. Then here what will happen? That electron, both that oxygen will take its electron, that is okay. It will take carbon electron also. That's why one negative charge will be created on oxygen, and carbon will have one positive, because it taken carbon electron also. Then carbon will have one positive. That's why carbocation is created. Now RMGX is there. RMGX, Grignard reagent. Then what will happen? What will happen here? That now that R and Mg bond will break. R and Mg bond will break. Then R is negative charge. R will be negative charge, Mg will be positive charge. Then this negative charge will go to the carbon, because carbon is positively charged. Then C and R bond will be formed. C and R bond will be formed. And now oxygen is negative charge. And now magnesium will become positive charge. One positive charge will be with magnesium. Then O and magnesium will join. O and magnesium will join. It will form OMG bond. OMG bond. Because O is negative charge, Mg is positive charge. Then now it formed, already I told you, R went to the carbon, which is positively charged, and now oxygen is negatively charged, that joined with MgX. Only one bond broken, bond between R and Mg of Grignard reagent. Only one bond broken. Hence it is already attached. X is already attached with Mg. Hence now what we got? Product is called adduct. Means now you got this CrOMgX. Cr. Now 2 valence is already left for alkyl groups or any other groups. And a third valency now used up in making the bond with R. And fourth valence is already joined with O, and O has joined with MgX. O joined with MgX. Hence product we got, that is the CrOMgX. This is called adduct. And this adduct, from this adduct, this product is called adduct. and this actually this product is very weak, unstable, and in next step, when it will react with H2O, then what will happen? Now that H2O, it will be in the form of H plus OH minus. It ionizes as H plus OH minus, water. Water in solution you can understand like this only. Water will be ionized as H plus OH minus. Then now what will happen? That this bond, O and Mg bond, is very unstable bond. This bond will break. And now O will obviously O will get negative, Mg will be positive. Then now H plus OH minus, H will go to the opposite, means O will go to, H will go to the oxygen. Then it will form OH group. It will form OH bond. Now you got the alcohol. Now O became OH. Then now that bond, OMG bond broken, H plus came to the O negative, and OH is negative, that gone with Mg. And now it form MgOH X. MgOH X. Mg has two positive charge, then one positive charge will be neutralized by OH, and other already it is X is attached, halide, and say other product will be MgOH X. Okay, OH is a negative charge, you remember. Then now M has two positive charge. Now one neutralized by OH, other neutralized by X. Then now you got here alcohol. Now overall reaction using different aldehydes and ketones, I will tell you. Overall reaction using aldehyde and overall reaction using different aldehyde and ketones, I will tell you. Okay. Same way what I told you, mechanism, now you can apply for aldehyde, different aldehyde and different ketone. Only R you have to, R value will change. R may be methyl, R may be ethyl. Sometimes R may be phenyl group also. If you are not telling any R, then keep two valency opened. Only C and 2 line you write. No group is attached. But it is expected that any group may come there. Then now suppose it is a RCHO. Individual example. RCHO plus RMGX. RCHO plus RMGX. Then now very easy, you will get now RCH2. RCH2 already HCHO is there. HCHO is there. Then 2 with carbon now 2 hydrogen is already there. Okay, 2 hydrogen already is there. Then RCHO. Then now same way what will happen, that double bond will break and positive and negative charge will be created. Same way then RMGX, that R will come to the carbon, correct, and Mg will join with O. What a adduct it will form, and means say RCH2 OMGX, it will form adduct. Okay, R is from RMGX. Then already HCHO was there, formaldehyde HCHO. Then already 2 hydrogen was there, and now 1 alkyl group joined. Then RCH2 OMGX. And again second step, hydrolysis H2O. plus H2O. Then now it will give two product. First it will give RCH2 will be there with O, H will come. Then RCH2OH plus with Mg, OH minus will attach from the water. Then it will form same way MgOH X. Then if you will consider, now I give an example for formaldehyde, HCHO. Now in the place of 1H, R is there. Then again RCHO plus RMgX. Then now with carbon 2R will be there. 2R will be there and only one H will remain and OH will be formed. First OMgX will form. OMgX will form because that will join with carbon. Here again you understand, all things are same. Only one RCHO was there plus RMgX is there. Then R joined with carbon. Then now 2R is there. And 1H is already there. Then now it became R2CH OMgX. Same way. And now again on hydrolysis, that H plus OH minus, then H will come to the O. Then it will form RRCHOH. RRCHOH plus MgOH X. Same way. No difference at all. Because that H2O will break, then H plus OH minus. Then obviously when OMG bond will break, O will get negative, Mg will get positive. Then H plus will come to O and it will form OH. Then now it became R2CHOH, alcohol you got, plus OH will go to the MgOH X. Then now here you have to understand, now you got secondary alcohol because 2R is attached. Carbon is attached with two alkyl group, R and R dash. Then both are maybe same or different. Then now it got, because it is attached with two alkyl group. Then alkyl group means what? That carbon is attached with the carbon of two different alkyl group or same group. Two group, both group may be same. Then the alkyl group always have carbon. Then now this time this is joined with two alkyl group. That's why it is a secondary alcohol. Now see how tertiary alcohol is formed. If you will take a ketone RCOR means R COO again R, left and right R two alkyl group is there and COO is there. Then again this double bond will break, carbon will have negative, carbon will have positive, oxygen will have negative. Now again RMgX Grignard reagent, that R will come and join with R, that will come and the R minus, that will join with carbon which is positive charge. Now there are 3R and now that fourth one is attached with oxygen, single bond now, and that oxygen is negatively charged because double bond became single bond, and from that oxygen again this MgX is attached. What always happened, again same things here. Then this adduct form again with H2O, it will react with H2O, then same thing will happen. Then now you will get again with OH will attach. Then now you got, you can say R3C means R3, now carbon has 3R, okay, CR3 you can tell, CR, and O became now OH. Then this is the tertiary alcohol because now this carbon is attached with three alkyl group. Then this is a tertiary alcohol, and another product will be MgOHX as usual. Then now you have seen that the reaction produces primary alcohol with methanol. Methanol means formaldehyde. A secondary alcohol with aldehyde, and tertiary alcohol with ketone. You remember, formaldehyde is known as methanol because in methanol only one carbon will be there. Okay, and that will give you, methanol will give you primary alcohol, and secondary alcohol you will get with aldehyde, and tertiary alcohol you will get from ketone. Okay, then now I have told you about preparation from Grignard reagent. Now actually one problem is there, I will discuss, then I will tell you other things. Actually question is that I want to discuss whatever possibilities there, that question I want to discuss, because sometimes same type of question may be asked in examination, but now you will solve easily, automatically you will solve because you are knowing many things now. Then now question I am telling you, what will be the product of catalytic reduction of butanol? Al means aldehyde, butanol means 4 carbon is there, butanol. This is the first question. Second question is that product you have to write, means and IUPAC name also you have to write, means you have to give the structure and IUPAC names of the products expected from the following reaction. Then first reaction is catalytic reduction of butanol. Second is hydration of propene in the presence of dilute sulfuric acid. And third is the reaction of propanone with methyl magnesium bromide, means MgOHBr. That is a Grignard reagent. Methyl magnesium bromide followed by hydrolysis. Then easily you can tell. Then first is the catalytic reduction of butanol. Then 4 carbons are there, and it is a CHO. Total 4 carbons are there. Then fourth carbon is actually CHO, that is called butanol is there, alcohol is there, OH is there, last is OH. Then butanol 4 carbons are there and OH is there. Then here what will happen if this butane 1 all, if aldehyde is there, then aldehyde if you will reduction you will do aldehyde, correct, means CHO, then it will give you what, that CHO that will convert to OH, correct. OH is there, 2H will be used up because double bond will break, then oxygen will have negative, carbon will have positive, then 2 hydrogen will join, then it will form means butanol aldehyde, that will give you alcohol, OL, all. Then its nomenclature will be very easy, butane 1 all. Second question is hydration of propene. Hydration of propene in the presence of dilute sulfuric acid. Then propene is there. Then propene means 3 carbon, CH3, CH2, CH3. Then here you have to do hydration means H2O, in the presence of H2O acid will be there, then what product it will give? Hydration of propene in the presence of sulfuric acid. Then propene is there, then obviously what will happen? That oxygen will be introduced. Means CH3, CH2, CH3 was there, and H2O will come, H2O. Then H2O will come, H plus and OH minus, OH minus. Then this OH minus will actually this in propene, 2C in the central carbon has 2 hydrogen, 1 hydrogen will break. Then hydrogen will go as a H minus. Carbon will have positive charge. Then OH will attach there. OH will attach there. Correct? And H went as a H minus. H went as a H minus, and there H plus was there, H2O. OH has given that attached to the carbon. Then H plus was there, that H plus and H minus. It will form H2, hydrogen gas. Then now you got actually alcohol. What will be its name? Then it will be propane 2 all, because at carbon number 2 alcohol is attached. Hence propane 2 all. Third reaction is reaction of propanone, means ketone, propanone. Then with reaction of propanone with methyl magnesium bromide, means CH3MgBr. This is the Grignard reagent. In the place of alkyl, now methyl group is attached, and in the place of X, Br is attached, bromine. So now same way it will happen, that double bond will break, oxygen will get negative, carbon will be positive, and then methyl group will come as a negative charge, that will join with carbon, and O will join with magnesium. Adduct will give again hydrolysis, then H will come to the O, and this OH will go to the Mg. Same things, means you will get alcohol. You will get alcohol because it is the propanone, means in the central carbon. With the central carbon, OH is attached. Then left side methyl carbon is there, right side methyl carbon is there. Correct? Then 2 methyl group is attached. Then it will be both side already 2 methyl group is attached, and third methyl group came from the this Grignard reagent, that CH3. Now it became 3 methyl group is attached. Then it is a tertiary alcohol. It will form tertiary alcohol. But what is the IUPAC name? Then with carbon number 2, OH is attached, and only with that methyl group is also attached. Hence you can tell 2 methyl propene, 2 methyl propene 2 all, 2 methyl propene 2 all, because only with carbon number 2 OH and methyl group attached. And this I have discussed about the lessons preparation of phenol, not phenol, preparation of alcohol from Grignard reagents. Okay. Next class I will discuss preparation of phenols. Preparation of phenols. It will be similar, but today I will not discuss. It will take more time. Next class I will discuss preparation of phenols. Thank you.